Thank you so much for joining us today, live from TC18. We are here today to talk about big data in the Big Easy. And just want to say thank you for our live audience for joining us. We're really excited. We have a lot to talk about. We have a lot of volume of things to talk about. I'm joined today by two of my amazing colleagues, Vaidi Krishnan, who's on our product team, and David Spezia, senior sales consultant. Welcome.
Thank you.
Thank you.
You guys have already presented sessions this week as well, right?
I've had a couple of sessions. I'm going to repeat one today and one tomorrow.
Excellent.
Yeah, I've done some sessions on calculations, which are very exciting. And I know Vaidi's got a session coming up on big data along with you, Spence.
Yep. So today we're here to talk about everyone's favorite buzzword, which is big data, of course. And I think we should just start with a little big data 101. More specifically, what does big data mean today?
Yeah. So let me start this by giving you a little bit of context around what big data has been in the last couple of years. So Gartner first came up with the 3 V's paradigm of defining big data, right? So they talked about big data as anything that was data of diverse formats, large volumes, and high velocity data. But in the last couple of years, what we've been learning is that big data is any data that will swamp traditional approaches of dealing with it. So any data that is requiring you to innovate around how to deal with it is big data. And I think that is going to continue to evolve. I remember when we did the big data session a couple of years back at this conference, our talk was titled, "What is your big data strategy?" Last year it became, do you have a big data strategy? And this year we called it advancing your big data strategy. So, the landscape evolves, customers are evolving, and we believe like more and more of data is going to get classified as big. So for me, it's all data today.
Sure. And you said dealing with big data, just having innovation to be able to kind of deal with it and handle it, and that goes just beyond analyzing it, right?
That goes beyond just analyzing it. It's ingesting it, prepping it, having the right compute resources to query it, and of course, having a visual analytics platform like Tableau to make it available to a broad range of users in an organization.
Yeah. And just to kind of put a couple follow-on points there on what Vaidi's saying, big data is kind of a general classification of technology, but I find it more and more as I'm working with customers, big data to be a relevant term or to what that customer is doing, right? Newer technologies to internet scale customers is a little bit different than customers that are adopting that type of technology for the first time. So the level of hand-holding, the level of coaching we're giving these clients is relative as they're adopting these strategies with these new data paradigms.
Sure. Yep. And so my understanding from what big data kind of meant, even 5-10 years ago, it's not just about Hadoop anymore. That was kind of, I guess, a gateway to a new era of data and analytics. How has that changed?
Yeah, I think Hadoop, when it was invented, it was originally devised for batch type use cases, but then people realized that scale out storage and computation at low cost could be used for analytics purposes. But now, as more and more organizations are moving to the cloud, as more and more organizations are re-architecting their data platforms to make analytics easy, we're seeing Hadoop as, or rather, big data being confined to not just Hadoop. A lot of big data is moving to the cloud, and those characteristics that Hadoop pioneered are made available in the cloud as well today.
Yeah, and just to kind of follow on to that, Hadoop makes a great storage tier, and we can store anything and everything there. But as analytics start to occur and they start to be driven by different use cases, we find that consumers of that data need a different lens put on the data. And when I say lens, maybe it's a structure, maybe it's a data stream that pre-aggregates some things, maybe it's a data stream that does some value add, maybe it's folks using tools like Papsata or Trifecta to munge up some of their own data sets and then make sense of it, right? So we got a great generic storage tier that's cheap and very cost effective. But as analytical use cases start hitting on that storage tier, they need these different lenses, and they're typically exposed through some sort of technology or technology partnership that Tableau has. So I think that's very important for us as this ecosystem continues to evolve. that we continue to innovate and have connectors and partnerships with these other firms that are producing technology that helps answer those use cases and really produces data in that lens the customer is looking for their ultimate end consumer.
Right. And just to add to that, I think just what Spezia said, we tell customers that big data platforms are not monoliths. They are an agglomeration of a range of components that you have to stitch together to match your use case. So a great example is, I as a customer, if I'm a retailer, a decision I need to take to know what to stock my shelves with if a certain product runs out, that is a decision I need to take within days, not days, probably minutes and seconds. But knowing what to stock my shelves with is a decision that could take days. But answering each of those questions needs a different architecture, right? So, as David said, one monolith is not how you have to think about these data platforms. You have to think about different tools for different jobs with Tableau as the unifying layer that connects all of them.
Excellent. And in thinking about these different architectures and different use cases, it makes me think a lot about data in terms of pipelines. Not everything is going through an enterprise warehouse anymore. Now you have different use cases that might demand accessing data from different places and being transformed in different ways. And I think maybe we could speak a little bit to how kind of data gravity has shifted to the cloud and how the cloud is driving not only that change, but also the ability to be more flexible.
Yeah. So it's important from performance reasons and for latency reasons that customers have analytics where they're storing their data. So that's the first thing. The second thing is, a lot of our innovation, a lot of our investments are aligned to ensure that customers can connect to data where it resides, and giving them the option to connect live or bring data into faster optimized in-memory stores. These faster optimized in-memory stores could be hyper extracts, or they could be warmer tiers of data, which could be an Exasol or an MPP data warehouse. But ideally, we want analytics to be done to be as close to where the computation and the storage of data is happening.
Yeah, in these cloud platforms, they're very competitive for cost of processing the data, and as more and more data continues to gravitate into the cloud, I find the flexibility there in ecosystem within GCP, within AWS, within Azure to be fantastic, right? Because like we talked about a little bit earlier, we have a generic storage tier, and then they have different database engines for different query loads, right? Analytical query loads versus pipeline query loads versus just generic storage query loads. And these things are very different, but you can store it in one way, and then you can move it up through the ecosystem to get closer to your end users, your consumers of data, and people that are exposing things through web and mobile interfaces. And that's fantastic, that in-cloud ecosystem, getting the data forward is fantastic, and that's one of the things I love about Tableau, is as you move data forward through these ecosystems closer to the end user and you process it further for analytics, Tableau has connectors into all of these tiers, so I can make an analytic at one layer, make another analytic at another layer as the data gets closer to an object, and then finally as it gets aggregated, I can connect Tableau to that too. And with our platform, we can pass actions from tier to tier to tier. So you can grab the context of a browsing session and then go, ooh, I got more questions about what happened on Tuesday in Arkansas. And you can drill down into Tuesday in Arkansas, ooh, I see I've got a problem at a couple of stores. You grab those couple of stores and then, ooh, I've got some interesting things going on with inventory at those few stores. And I would imagine those data sets to be aggregated and stored in slightly different mannerations and in slightly different compute stores. So it's fantastic.
Yeah.
I'd also add that, if you look at each of the cloud vendors, they have designed their services to support different kinds of use cases, like David talked about. So if I am an analyst who wants to do ad hoc, so if I'm, let's take AWS for example. If I'm an analyst and I want to do ad hoc research and discovery, Amazon has something called Athena that I can use to directly query my data lake with Tableau. But if I am more interested in operational monitoring and KPI insights type of use cases, type of use cases where the insights are packaged and production ready for day-to-day decision making, Amazon has something called Redshift, right? So depending on the question you have, depending on the level of granularity at which you want to explore your data, there are different services, all of which could be part of that data platform. Yeah.
And just to kind of follow up on, you're talking about different kinds of data, different levels of data. As then you said something earlier about like warm data, and I'm assuming that means that there's also cold data. And I'd like to kind of get into what different types of data those are, and how they're structured and how these different types of data might be used.
Right, yeah. So first of all, I want to dispel the myth that cold data does not mean it is data you shouldn't be touching. It just means it's data in its rawest, most disaggregated form. But there are many, many needs that might require you to touch that cold data. It could be billions and trillions of records. So I could be a data scientist who wants to understand what are some questions worth asking. I don't even know what questions I want to ask. And I will query that cold data, and the answer is going to tell me what subset of that data is worth persisting into a warmer tier to further provision to my business users. Right, so that's the first thing. The second thing I'd say is, at Tableau we have built connectors into all cold data storage formats, whether if you're in HDFS or in a Cloudera, you can live query via Impala. If you are on, if your data lake or your cold store is Amazon S3, again, you can use Athena for that. So we want to encourage ad hoc discovery, but also provide a path to bring that data into a more structured way for more reasoned, repeatable analysis.
Yeah, and as we move through different tiers, we may use the terms cold, warm, and hot. It really refers to how much processing has been done on that data. How raw is it? Is it split up JSON? Is it text? Is it log lines?
Actually, Spezia had coined a few other names for those tiers, right?
Yeah, definitely. So like a raw data, the rawest of raw data, and then you have that data that goes from raw into something that looks more like an object. Something that we're used to from the enterprise data warehousing kind of paradigm that we lived for many, many years in databases and reporting. So it's got something with business definition, like myself, right? I'm a customer and I have a location, I have a demographic, I have an income, right? I have certain purchasing propensities and I'm being scored through, right? I'm an object. But then my purchases over time, as I shift through the different segments, that might be processed even further and aggregated down even more, so it's in an analytical structure. So I'm in a raw structure, and I have compute engines or query engines that are a little bit slower for analytics, and then I have this more object level store, which has traditional style query engines that are used to doing updates, inserts, and selects. And then I've got these analytical structures, so I'm going to store the data analytically, make maybe in a Parquet format or some other format, an Avro format, to do faster analytics. And then the query engines I have sitting on top of these storage formats are designed closer to MPPs and closer to compute engines that more quickly answer analytical query types.
And I think it's also worth mentioning that the best of breed customers have thought about their architecture that way.
Yes.
And in order to be successful or enable a range of use cases, you have to address all those things.
Sure. Yeah. And it's a balance. How much do I want to pre-process? How much do I want to post-process? And how much do I want logical definitions that might speed up things with caching and smarts that understand what users are asking for? And that's exciting about this space right now.
Yeah. Well, and then what you said leads me beautifully into my next question, which, we are trying to get big data to be more self-service, and I think those considerations, making it more accessible, are huge. And I would love to talk about, a little bit more of the promise and then some of the challenges around self-service with big data.
Yeah. So, I'll give you an example. So, the challenges around for customers are mostly reconciling the fact that you have to address the needs of governance and compliance and oversight of data with the need to unleash your data and enable self-service analytics. And when the two come together, it can be a tsunami. It's not easy. So a great example is when GDPR happened. it came at us too quickly, and customers were, well, here's 15 other needs I had never considered that I need to now address. So that's the first thing. The second thing is not everyone has thought about the different storage and compute layers, and not everyone has thought about the different types of use cases that might emerge in their organization. So it's if your architecture is not agile, if it's too one size fits all, it is hard to change back. You know, once you start building things out, once you've made a long-term investment, and once these, you know, you've invested in components that cannot be, you know, mixed and matched, you run the risk of over-investing, and then you can cut back and address other different use cases.
Yeah, and you know, for the users that are consuming big data in a self-service tier, you know, there's a few things we're always concerned about. Can they find the data they need to answer those questions? Once they find it, can they trust it, right? What's the lineage of this data into this data lake, or into this table, or into this analytical structure? And then finally, you know, once they have that lineage, how can they expose that lineage and that trust to other people? And so we see technologies coming in to fill the void for finding, governing, and trusting data, right? So there's loads of data catalog vendors that are focusing quite heavily and quite brightly within the data lake / big data space, right? And so they're exposing not only raw data, they're exposing tables, they're even exposing, some of them they're exposing queries that end users are pushing in there, because the result set of a query that an end user sends from a tool like Tableau probably has more analytical value than something that's just sitting in a raw JSON string, right? And so I love the vendors that are exposing these things. So either Calibras, your Elations, your Waterline Datas, all of these tools, and the Unify software.
And almost every customer I've spoken to has some level of metadata integration. So to give you a couple of examples, you know, Airbnb comes to mind. They use you know, Amazon S3 heavily, and they have Cloudera HDFS as their storage layer. But they also have a Hive Metastore, and they use Tableau on Presto to query partition Hive tables, but they have that metadata integration to query the data about data. So cataloging, having lineage, and knowing very deeply how a particular data element was created. That is very important. So, and as David talked about, we have several partners that come to mind. Elation is one, Unify. Informatica has a direct integration where they have cataloged all of Tableau Server along with other data warehouses that a customer may have deployed, and they have integrated this via a browser plugin. So there's a lot of integrations we have, and there's a lot we're continuing to work on. And several of them are here at Tableau Conference.
Excellent. Yeah. So it sounds like just in the larger scheme of things, you know, when we talk about these kind of like end-to-end big data architectures, there's a lot of influence on data and analytics that come from these other components and how you integrate. And I'd be curious to talk a little bit more about some of these vendors and some of these kind of like, you know, buckets of technologies. And maybe we can start with ingesting and prep.
Yeah.
Because I know, you know, with big data and a lot of the technologies that we're seeing today in digital transformation, streaming data is really, really changing, you know, the volume and velocity and use cases that we have for data. And I think that comes into play as well.
Yeah. No, so so if the question is more around the types of technologies that assist with each of these processes, is that the question?
Yeah.
Yeah, great. Yeah, so for ingestion, we have a lot of partners. You know, there's this Trifacta. We also you know, work with Paxata and a few other, and Informatica has you know, so technologies to assist with data ingestion. AWS, all the three cloud vendors have data ingestion frameworks. And we've seen Tableau not necessarily directly you know, connecting these ingestion technologies, but these ingestion technology will pipe data into Hadoop or a warehouse, and Tableau will sit on top of that, right? So that's the first thing. David, you want to add to that?
Yeah, definitely. we talked about movement through the different tiers of data as it becomes more analytically useful, prepared more for tools like Tableau. And we see movement happening, to me, in the three broad classifications, if I were to put it down there. A lot of your PhD, your data scientists, they're going to be moving data with code, right? They're going to be writing Python scripts that are going to go out there and value add to the data and then structure it and move it somewhere else for others to analyze. They might be calling out and doing some statistical additions to that data as well as they're looking at these massive data sets. Then there's tools that natively use the Hadoop ecosystem to do their execute. Right, tools like Unify and Trifacta that were built with a UI, but that UI then breaks down what they're doing into queries designed to run on Hive or run on Spark.
Use the Hadoop compute engines to do a lot of that stuff. Yeah.
Right, so their native compute engines are those. And then you've got tools more like Tableau Prep and Alteryx, where they have their own compute engine, but they've got large ecosystems, they've got large customer bases, they've got a lot of expertise in the field that also have connectors down to these different big data stores. So there's kind of those three broad classifications, and the larger enterprises have all three, right? There's no one way to do it. Right. And so we'll continue to see that evolve, continue to see tools that have UIs do more and more what the data scientists are doing within Python and do more native execution within that big data stack.
And I believe even going forward, none of those methods of moving data is irreplaceable, really. The data scientist, he likes to code Python and Scala. He has special needs that may not be the same needs as that of a business user. So there's a place for all those.
Excellent.
Yeah.
Next, let's talk about storage. And maybe we can kind of speak on a little bit about the evolution of data lakes and some of the partners we work with in that space.
Yeah. So, we obviously talked about Hadoop, and contrary to certain things many of us may have heard, Hadoop is not dead. I think we have a lot of customers still on Hadoop. Cloudera and Hortonworks, they just merged, so they're going to combine a lot of their technologies. It's still state of the art in many ways, but what I would say though, that a lot of where big data workloads are being stored is moving to the cloud. So we have Cloudera and Hortonworks. We have all the three cloud vendors: Amazon with S3, Azure with Blob Storage, and Google with I forget what's their equivalent of S3. Yeah. But they all have some sort of cold stores. All of them, they have modern data warehouse as well. So Redshift for AWS, Azure SQL Data Warehouse for Azure, Google BigQuery. We have Snowflake. A lot of customers using, are moving to Snowflake as well. So it is an evolving landscape. A lot of players, but our approach has been to enable customers to wherever they want to go, right? We do not influence the choice of database. We do not influence the choice of where they want to deploy a lot of that, the data lakes. We will have connectors, and we will have a way to bring data into Tableau from wherever customers have it.
Yeah, and I see a lot of the evolution of storage and kind of putting query engines and database engines on top of that storage really being in the cloud, right? Going back to that cloud gravity. And then independent vendors like Snowflake, who grew up within AWS, have recently moved on to Azure. Onto the Azure platform. Yep. And if I was a betting man, I would say they're probably also going to target the GCP cloud platform as well, right? Because we love it when we can store the data in this raw format and then do smart processing on the data to put it into the engine that better answers the use case. And so we'll continue to see it go there, and storage formats will continue to evolve just to handle those use cases as we see the variety of those use cases change, and really as we see things that would have probably been core delivered out of EDWs in the past now being delivered out of that modern stack.
And while all of that happened, let's not forget that spreadsheets aren't going away. So there will always be the need to integrate an analysis that you've done on billions of rows with a new spreadsheet that you've been given. And we have tools like Tableau Prep that extend what's possible with the big data platform to the daily business use.
Perfect. Let's talk a little bit about query acceleration. In some ways, it's kind of blurred the lines between traditional data warehouses in this world of big data. Who's doing it and how?
Well, first of all, Tableau is doing a lot of query acceleration. Since the launch of Hyper, we have achieved faster extract creation, as well as, of course, faster querying, and that's an area we continue to innovate on. Internally, we have projects to accelerate dashboards, optimize how Tableau is sending queries to different data sources, so that's going to continue to happen. I know also that Redshift and Snowflake and all these MPP data warehouses, they're investing more and more in more smarter caching. So if we're fired a query, and if we're firing a similar query that is going to leverage some of the data elements, do I have to send that same query back again? Could I reuse some of that data? So caching, smarter querying, and we also have purpose-built acceleration platforms like AtScale, like Jethro, like Kairos Insights, and all they provide a semantic layer between HDFS and Tableau, and they will essentially create an OLAP cube on top of that to make KPI type queries faster.
Yeah, and there's really two approaches for query acceleration, right? You can aggressively pre-compute in anticipation of answering questions, or you can logically post-compute with smarter caches. Right, so there's tools like Exasol and Vertica, the MVPs of the world, that will aggressively pre-compute stuff into analytical structures, and then when a query comes in, that query is handled highly parallel.
Right.
So they can answer that question faster. This is very similar to our Hyper technology, right? We aggressively pre-compute stuff into a Hyper file, and then our Hyper engine can scale out to n number of cores to break up that query. I myself have pushed an AWS X1 machine to 128 cores of full utilization.
Yeah.
That was fun, right? Because the technology will scale that way. And then there's the logical players, the AtScales, the Kairos, where we're going to put some definition on top of it that feels like a data model. With AtScale, it really feels like a cube model that I'm building. And as queries come into that model, we're going to cache things, and we're going to anticipatory cache things as well to answer those aggregate queries. And if we don't have what we're looking for, then we'll go query the big data engine. So that logical storage layer is really interesting when you get to large scales, and you don't have enough time to pre-process everything. So I really see combination of both of those things being effective. When I have data scientists or analysts working with data, doing the logical compute is really interesting to me, or I might have a couple of sub-tabs within a dashboard where I want really detailed information that's blended between inventory and transactions. I love the logical model for that. But then I can be more aggressive and pre-compute things for my starter dashboards or my landing dashboards and use things in combination. There's no one way, but I think both technologies are interesting.
So a question I would ask you, David, is between optimizing in the dashboard and optimizing in the database, what is more effective, and what have you seen customers do more?
Yeah, so that's a great question. Tableau itself is an aggregate SQL pass-through engine. That's what we do. If we got paid to write lines of query, boy, we'd be paid really, really well. We write loads of them. And so I always take it back to the customer and I say, hey, where is this data being delivered? Is it being delivered through more than just Tableau? Right? If that data is being delivered through more than just Tableau, then that's an easy answer to the question. Hey, we should go back into the database, back into the data pipelines, back into the ETL, and move the logic down into that.
Yeah, push down compute is something we hear a lot, and that kind of aligns with what you're saying,
Yeah, and then sometimes it might just be a couple of widgets on a dashboard that has no other destination than Tableau. Then we can talk about making things more simple in Tableau. We can talk about maybe putting things into a hyper extract that matches that individual viz. But it's a broad conversation. I find more push compute down to the data tiers as opposed to in Tableau, but we can handle it both ways. And it's probably a 65-35 split for me. I get involved in a lot of these performance concerns. Hey, where should we accelerate the performance? And so that's about what I'm seeing from my general experience.
Maybe let's talk a little bit about what customers should keep in mind when they're building out their big data platforms.
Yeah, I mean, I'd say three things. First is, and we're actually talking about this in our session, is they have to keep that data pipeline agile. So in other words, it cannot be Tableau and one data warehouse for all your use cases. Or it cannot be Tableau plus Hadoop for all your use cases. You have to think intelligently about the different kinds of questions people will be asking, the different levels of granularity at which you may have to store your data. You may have to ask about how often that data gets accessed, how frequently people will be interacting with that information. So a range of things need to get considered. That's number one. Second is, and this is something Hadoop did really well. You have to decouple storage and compute. A lot of the modern cloud data warehouses do that. Snowflake does that. Redshift does that. Azure SQL Data Warehouse it does that too, because we live in a world where you are paying per query. So you're paying for use. So while your data gets aggregated in a warehouse, not all of it is going to be used immediately. So you want to separate storage and compute, so that way you can optimize for the Monday morning spikes and not overpay when Friday afternoon no one's asking any questions. Right? So I think those would be the two. But of course, you have to also accommodate for the fact that you're going to have multiple data sources. Not everything's going to be a flat file. There's going to be some JSON, sensor data, text data, right? And you have to optimize for multiple personas. Not everyone in your organization, and this aligns very well with how Tableau has modified how we provide software to customers, with our role-based pricing that we launched earlier this year. But not everyone is an analyst. Someone is only interested in looking at the information, and someone is a data scientist who's doing a lot more than just analyzing data. They're integrating with data with several other things. So those would be the three things I'd say.
Yeah, so I like to look at it from three components as we're starting to design a big data architecture for analytics at a company. Right, I want to look at the roles and personas.
Yep.
I want to look at where is their data / how is their data stored today. And then I also want to know, do they view their data as an asset that they can use internally for competitive advantage, or is it also something they sell, right? Some of these clients do sell that data as a service as well, right? And that will drive the tool selection a little bit, right? So when I'm talking about roles, what are my data admins? What do my security and compliance mix look like? Do I have data architects? Do I have data engineers? Do I have data stewards that make the data I collect available to the business? I have hardcore analysts that'll do statistics and things. I've got regular analysts.
Yeah.
I've got consumers with tools like Tableau. You've got Consumer Plus, where people can go in and open up dashboards and run some of their own queries. So that makeup, especially that persona makeup, will really drive some tool selection. Of course, where your data is stored today will drive some tool selection, because you'll already have some expertise and you'll gravitate towards tools they may know or be familiar with as well. And then really that data, is it internal competitive advantage, or if I'm going to be selling it as part of a service, I'm going to have a higher rigor on uptime, I have a higher rigor on quality that I also need to be aware of. So I may have some specialized tools that assure high uptime and high quality as well.
And if you think about customers who are really successful with their big data platforms, maybe they've got they're data driven, it's just built into their DNA. What are some of the things that you see that are really common with these types of customers?
Yeah, the one thing I'd see is they all have, first of all, they are committed to making data available to everyone within the company. Right, so they have a commitment to self-service analytics. That's the first thing. Second is they have invested a fair bit in data engineering. So to architect data platforms that are smart, that will respond to different use cases. You have to have the engineering expertise in-house, or with the help of a partner. make design changes as your needs evolve. And a lot of our best customers, be it Netflix, Airbnb, Ebates is one we talk about a lot. They all have that expertise in-house. So those are two things I'd say. You just cannot do that.
Yeah, and there's some kind of organizational maturity at some of these companies
Yep.
that you mentioned, these internet scale companies, even the Netflix of the world and others, where they have their own internal data engineering teams, and they even have some of their own internal data product managers, right?
Oh boy, tell me about that, yeah.
Right, because they're not only consuming tools from the market, they've got so much expertise, they're building some of their own tools to answer some of their own questions. And that's also part of this ecosystem, and we see, smart tools, like just Hive for the low-hanging fruit that it is, right, created by Facebook, and then that was pushed out there into the community, and then it was started to be,
Right.
commercialized, right? And we're also seeing things like that. So the ones that have been the most successful are the ones that have those teams that have their
Right.
own data engineers, they have some of their own data product managers, and they just feel that data is such a competitive asset
Yep.
that they can turn it into an internal product. And they're also really, really successful at promoting themselves in the community,
Right.
in the community that's sitting on top of Apache, as well as internally. They're really good at saying, hey, look at all these great things we're doing
Right,
with data,
right.
and we're doing with our data products and our data vendors, right?
And the other thing I'd also say, David, is all these companies that you talked about, without exception, for all of them, the analytics group internally is a competitive asset. They all have wide business visibility. They may sit in IT, they may sit in business, but they deeply influence decisions at the CEO level. So that's very important. If analytics is is an aftermath, it's a byproduct of a lot of things, you will not ever get buy-in to make the level of investment you need to curate and design and continuously evolve your big data platform.
Sure.
So it has to be on the CEO's agenda.
Yeah. Well, I think we're running out of time, but I wanted to say thank you guys again for joining us. One thing that you said about data being a competitive asset, I wanted to just remind our viewers that tonight we have the Iron Viz, which is going to be really competitive. So tune in to TC Live, keep watching, and thank you guys again for joining us.
Thanks
today.
for having
Appreciate it.
us.
Yeah.
Thank you so much. It was an absolute pleasure.
Thanks.
Awesome.